A fraction can represent a part of a single object. For example, the spinner has 7 sections. One of these is green. We put 7 in the denominator. That represents how many in the whole. And in the numerator, we would put 1 for the number of parts we're talking about. 1/7 of the spinner is green. If we want to see how many red parts there are, there's 1, 2, 3. Those are the parts. That's 3 in the numerator. There's still 7 in the denominator, so we have 3/7 of the spinner being red. A fraction can also represent a certain number of a set of objects. For example, 3/10 of a set of 10 bowling pins is still standing. We can see 1, 2, 3. That is the part of the set, and all of them in the set would be 10, 3 over 10. 7 of them have been knocked down, so that's 7/10 of the set has been knocked down. It's important to understand that fractions can be expressed in different ways. It's still the same amount of area regardless of how many pieces you cut it into. So here we have 8 parts in the circle. 1, 2, 3, 4, 5, 6, 7, 8. That's our denominator. And 2 of them have been shaded in, so that's 2/8. We can also see just by looking that this section here, that's 1/4 of the circle. Each 2 of these eighths is 1/4. So here's 1/4, 2/4, 3/4, and 4/4. So we can say that is also 1/4 of the circle. These are called equivalent fractions. Equa means the same, as in the equal sign. Valent has the same root as value, so it means having equal value. If you have 30 students in your math class, 15 of them are boys, you could say that 15/30ths of the students are boys. 15 is the part we're talking about. 30 is the whole. It's the total number of students in the class. However, you could also say that 1/2 of the students are boys. Those have the same value. 15/30ths and 1/2 are equivalent fractions. To find that, we would divide both top and bottom by 15. 15 divided by 15 is 1. 30 divided by 15 is 2. Since we're dividing by 1 over 1, it does not change the value. Anything divided by or multiplied by 1 has the same value. In this spinner, again, we have 7 sections. They want to find out how many of them are blue. There's 1, 2, that's our numerator. 2 over 1, 2, 3, 4, 5, 6, 7, 2/7. Next, we have 24 students in the class. That will be our denominator. That's the whole, the total number of students in the class. They want to know how many have a pet dog. It says 17 of them do, so that's the part of the whole. That will be our numerator, 17 over 24. Here's a triangle. Looks a little different, but the same principles apply. We have 1, 2, 3, 4, 5, 6 sections in the triangle. So each one of those is 1/6 in the bottom. That will be our whole. That will be 6. 2 of them are shaded, so we have 2 out of 6 shaded. But you can also see that each one of these sections here of the 2/6, we have 3 of those groupings. So each one of those is a third. 2/6 is the same as 1/3. And we get there by multiplying 1 over 3 by 2 over 2. 1 times 2 is 2. 3 times 2 is 6. We're multiplying by 1 to get our equivalent fraction. If we invite 8 friends to a party, but 2 of them can't come, what fraction can't come? What's the whole? 8. We're inviting 8 friends. How many of them cannot come? That's the part we're interested in. That's 2. So 8 is our denominator, 2 is our numerator. We have 2/8. Divide both sides, both top and bottom, that is, by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. 1/4 is our simplest form. If the numerator and the denominator of a fraction are the same, the fraction is equal to 1. 2 divided by 2, that's 1. 3 divided by 3, that's 1. 6, 10, 54. Anything divided by itself is 1. It can be anything in the top as long as you have the same number in the bottom. The one exception is 0. We do not divide by 0. And here's why. Here's a circle. It's divided 1, 2, 3 parts. One segment is 1/3 of the whole circle. So if we have 2 segments, that's 2/3 of the circle. 3 segments, that's 3 in the top, 3 in the bottom. Those are the same, and we can see if you have the same number of parts as the total number of parts in the whole, that's going to be the same thing as the whole. That's one circle. You can show fractions on the number line, just like integers. They work just like integers. So if we think of 1 on the number line as representing one whole, we can write it like this. Here's 0, here's 1, and we'll have this be one whole, this line segment between 0 and 1. They've divided it into 10 sections. Each one of those is the same value. So if we want to put 1/2, if there's 10 of them, 5 out of 10 is 1/2, so we go 1, 2, 3, 4, 5, that's 1/2, and we can see that's halfway along the number line. 4/5, well, each fifth is the same as 2/10, so here's 1/5, 2/5, 3/5, and 4/5. So that's where 4/5 goes on the number line. If the top, that is the numerator, is smaller than the bottom, what we also call the denominator, the fraction will lie between 0 and 1 on the number line. So let's show 1/10 and 3/10 on the number line. Here's our number line. Let's divide it into 10 sections. So 1 is the same as 10/10. So we're going to go to find 1/10. Well, each one of these is a tenth, so that's 1 right there. Now where's 3/10? Well, we have to go, that's 1 again, and we get over to 2, and then to 3. So there's 3/10.